company from northern Italy. We develop a software application which is completely open source, which is also called CrateDB. And we try to bring the DevOps methodologies to infrastructure. So trying to automate and compose actions on your infrastructure rather than on applications. So for example, you may want to automate the creation of virtual machines, you may want to automate the creation of pipelines, rather than technically anything else that has an API. I will not go into too deeply into that, because this talk is more focused on the GreenOps aspect of what we are trying to do, and also a little bit of the FinOps part. So since we can say that the FinOps component and the GreenOps component, for some aspects, are sort of similar. So when we are talking about green software, we want to know, we want to use efficient energy. We want to be efficient. We don't want to waste resources, and we want to use our resources when the energy is greenest. So this usually applies to software. So we think about software, especially if you look into the Green Software Foundation, which I'm not affiliated with, but they exist, and they talk a lot about efficient code, like what are the libraries with the least impact, CO2 impact, which are the methodologies to reduce the carbon emission of software. But we can also look at the infrastructure, like what can we do to improve the carbon intensity of our infrastructure. I think it's, yes. So I think the problem with efficiency starts from visibility. I could almost bet on it that each and every one of us happen that we go outside on vacation for an holiday, or we go out for example, work, and we leave the light on, we leave the stove on, or the air conditioning. Then we come home 2 weeks later, we have no idea, we find it on, and it's a problem. We spent a lot of money for nothing, we wasted a lot of energy, and we had no idea to know what was going on. So we had a problem of visibility. We didn't have an immediate feedback on what was going on. So can we do anything about it? And to bring you another example of the concept of instant feedback based on visibility, many of us, or at least some of us, will probably know or have driven an electric vehicle, or an hybrid vehicle. It also applies. And these newer cars have a little gauge that will tell you how you're driving, your driving style. You know, there's sport, eco, and based on how much you press the throttle, it will go up and down and tell you when you're efficient, where you are. And this simple indicator alone makes drivers more efficient. I mean, the car is itself more efficient, but they are also driven more efficiently. And that is all thanks to this little gauge, which is doing nothing. There is no optimization, there is no AI, there is nothing, it's just a gauge. So we need to do the same for our infrastructure. We need to apply the same principle, we need the same idea, we need to know what is going on. We can't have our light left on, so to speak. So, what? Oh, well, of course, there's also the FinOps component. So, we are now thinking about emissions. We can also look at the other side, and we see that usually what drives change, especially in companies, both small and large, many companies is cost. Like, it's very difficult to go and say, yeah, if we do things differently, we are going to be more carbon efficient. That usually brings nothing. However, if we say, look, we can improve our efficiency and reduce costs and also carbon emissions, that usually gets things moving faster. So FinOps is usually, FinOps practices and GreenOps practices somewhat overlap. Like there is a lot of overlap where increasing the infrastructure efficiency also like applies to both FinOps and GreenOps practices. So can we do something more? Yes, we can. We can increase the, we can scale the infrastructure and decrease how much hardware we are provisioning for our virtual machines. We can turn off infrastructure when we are not using it. If we have, for example, it often happens that development or test environments are left running 24/7, just like production environment. But this is not necessary. We don't need to keep them on. And if we turn them off, we could save both money and energy, and therefore carbon emissions. So what we decided to build, and we also collaborated with the University of Trento in northern Italy to try and find a solution to this problem. And we used open source tools, so you can see we use Kubernetes, Prometheus, CrateDB, but that's just a database. It could be anything else that supports time series. And also Prometheus itself would work just fine, but we use it for other stuff that's not relevant now. And open policy agent. So with this approach, we built, I'm going to skip this for time, sorry. We built this architecture. In this architecture, we use Kubernetes as our backend. As I said in the introduction, CrateDB is based on Kubernetes, and everything we do is declarative and is a custom resource. We use operators to provision everything, the environment and also the monitoring. So with a custom resource, we can call the correct operator to provision whichever resource we want that is part of the infrastructure. And then from these resources, we can collect metrics and know what they're doing. Additionally, we can also collect carbon intensity data. Our data centers, both if it's an on-premises data center and if it's a cloud data center, we know where they are. So we can look at the grid energy, grid carbon intensity for the energy we are using, and find out, based on the work we are doing, how much that energy is, what is the carbon intensity of that energy. So then we can use OPA policies, so Open Policy Agent policies, and optimize based on the data we collected, build an optimization, compute an optimization, and make a closed loop optimization and apply it back to the custom resources that we made. So it's basically continuously monitoring and optimizing our resources and our infrastructure. And how do we do it? Well, the first step is right sizing. Since we are constantly monitoring, we are gonna know when we are wasting resources. For example, when users are left with the choice of deciding how large they want their virtual machines, they are usually, do you want 2, 4, 8 cores? Well, I want 8. And maybe they're not going to use that. We can find out, and we can reduce these, or suggest. Just, no sysadmin is going to want to cut resources automatically. Nonetheless, we can find out and know that we are wasting some resources that could be allocated to someone else that perhaps is saturating the usage. Then we can turn off unused infrastructure. When we have a machine especially for businesses, these machines are usually not used during the night, they're not used during the weekend. As I said before, development and testing environments do not need to be on during the weekend. So we should turn them off. And this saves both money and electricity. And finally, we have, and these first two were the FinOps and GreenOps parts and techniques overlap, which is optimizing costs and energy. And this final technique is GreenOps. It's 100% GreenOps. It's not going to save money. However, this applies mostly to cloud environments, but it can also apply to on-premises environments, which is geotemporal shift. So, if we have multiple locations where we can use, where we can put our workloads, we can decide based on the carbon intensity of the grid that we obtained before, where to put this workload. For example, here in France, we have there are many nuclear power plants, so carbon intensity for energy is really low. We could also consider temporal shift, which is, for example, if I have some slack between when the workloads arrive and when the workload duration and the workload deadline, so we can move when we run the workload. We can also shift it temporally. For example, if our workload lasts, let's say, we expect it to last 4 hours, and it arrives at 21 in the evening, we can say, I'm not going to run it now, I'm going to wait 9 a.m. tomorrow, because the sun will be up, and I will have cleaner energy from solar panels. And this technique alone will reduce by approximately 13% alone the carbon emissions, which is a lot when we think about data centers. So in conclusion, what I wanted to bring in this presentation is saying that there is a rather large overlap in optimizing costs and in optimizing carbon intensity. As I mentioned, we did cooperate with the University of Trento in Italy. We wrote a scientific paper. It's currently under review. We have a preprint available if you want all the details and find out exactly how everything works. There is a lot of details on CrateDB, how the platform works, how we interact with Prometheus data, and all of that. That's it. I think we'll give if anyone, any question? No? Yes? I'll go first.
Just for the right sizing of resources, CPU or memory, already open source tools like Prometheus, and my question is if you are using GitOps and we precise the resources, the CPU and memory, and if your tool is trying to modify the right size of deployment or stateful set or whatever, so how it works if we're already using the Algo CD for GitOps?
That's a good point. This approach does not, I'll try to keep it short in the interest of time, but this approach is not limited to Kubernetes deployment. It can work on Kubernetes deployment, but it also interacts with, if you want later I can show you, we have an example on both Kubernetes deployments, but to scale the request and limit. And we also have a change on virtual machines on Azure Cloud and also on AWS with OpenShift technically. So it's scaling a bit whatever you want, because you can, in the policy that you write on open policy, that's to incomplete the language, and you can really do whatever you want. So, and the interaction with Argo CD there is probably going to be a conflict if the customer source comes from a pipeline. If the policy changes directly the customer source. However, Open Policy Agent can make HTTP calls, so technically you could go to the source to Argo CD and continue and change where the loop closes.
Okay, nice work.
Thank you.
And I don't understand which kind of data you use. You have this picture with the loop, etc. And
Yeah.
the one carbonate intensity data,
yeah.
and also the part on high inference. So you use a special model or to interrogate data, etc.
Yes. Thank you for that question. The carbon intensity data is spatial and temporal carbon intensity for electricity grid. We had a partnership and used the data from Electricity Map, which provides data for approximately, let's say, about city-sized regions for in the 24-hour period for the whole year. No, sorry. It's updated every 5 minutes, and for the whole year. And we use that data combined with the position of data centers around the world, which are public, and combine the data in a policy. The inference models are really tiny models, and it's if you are familiar with inference model, it's the tiny time mixers, TTMs. It's a very recent paper. It's a super efficient, super small model, runs on a few megabytes, and it's used for forecasting the carbon intensity of the grid in the future.
Okay, nice.
Any other question? We're good? Thank you.